Hello everybody, welcome back. Today we're doing 5.4, the normal distribution. I've broken this up into two parts. Today we're doing part 1 in the first video. And we're talking about normal distribution. So a normal distribution is a type of frequency distribution that occurs commonly. It's one of the main curves that you're going to use in stats. If you take a stats course in university in the first year, it measures things like height, mass, length, and normal distribution. It's used quite a bit. So normal distribution graph, the graph is actually continuous data. Okay, continuous data. You've heard that term before. The distribution's mean, median, mode are at its center. We'll talk about what that is, where that's located. The graph is symmetric, as you can see here to the right. It is symmetric about the mean. So you can see this mu here. We have the mean, and it is symmetric about the mean. So this side is symmetrical this side. We've heard those terms before. The total area under this curve, we'll talk about that, is 1. All right. Area under the curve is 1. And the area under a normal curve calculates the probability that an event in that region, shaded region, will happen. Okay, so the graph of normal distribution depends on two factors. The mean, mu, which is the measure of central tendency, and the standard deviation, sigma, which is the measure of dispersion. We're going to explore that in a minute here. So remember, the total area under the graph is 1. Okay, so under here is 1, because 100%, essentially. Example, we'll look at a normal distribution with mu is 67, and so the mean is 67, the standard deviation is 5, is shown below. Right on top of that, we're going to sketch normal distribution with mu equal to 77 and the same standard deviation. So essentially what it's going to do, it's going to slide the curve to the right. So what I've done is I've created this in Desmos for you. Okay? And here it is. It has this beautiful curve that I've created in Desmos. You're not responsible to do that in Desmos. You can just do a sketch. But I really want you to see it. Okay? There we go. So this was the curve that you originally had on your sheet, and what I did is I literally slid it to the right. Now the mean is 77, and I drew the same curve here. And there's a standard deviation of 5, so that's right here. It would be at 82 now. It was at 72, and now it's at 82 because there's a 10 difference in the mean, right? Okay, we'll talk about this. Like I said, this is just to get an idea of what happens when the mean changes and when the standard deviation, or if the standard deviation changes. I'll show you all the calculation parts coming up, but this is just to get an idea of what happens. Okay, so the new graph has a different center, but the same dispersion. Okay, and this area where you see where it's shaded underneath the original curve, this area is equal to 100%, or 1. Okay, and we'll talk about that when we get into the z-scores in 5.5. Alright? Let's take a look at a sketch when we have the same mean as we have here, but a different standard deviation. So obviously that's going to disperse the data a little more. So I'm going to do that graph for you in Desmos as well. So to sketch a normal distribution with the same mean, 67, but a new standard deviation that's double, you can see that we have the original curve that you have here, but this one here it's much flatter, so it's not as steep, right? Because remember, the area under this new curve that we've created is still 100% or 1, right? So the new graph must have the same center, but a different dispersion, and the curve is not as steep as you can see. Okay? So let's apply this to this example. It says the height of 1,000 Canadian males ages 20 to 39. and they already have created a histogram and a frequency diagram. One, you can see that the curve is normally distributed, right? Normal distribution. Remember, the mean is in the center, and it looks pretty much symmetrical. It doesn't have to be identical, like exact, I guess, but it is symmetrical. Okay, it gives us the mean at 69.5 inches, and the standard deviation is 3 inches. All right, so the heights within one standard deviation, we list this as, so the heights within one standard deviation is equal to the mean plus or minus 1 standard deviation. All right, so to obtain that, we just do that. So we say that we have 69.5 inches plus or minus 3.0, which is equal to, or sorry, we'll do minus first, minus 3.0, which is equal to 66.5. And then we do the same thing, but we add, and we get 72.5. So we can say, based on the inches given here, since our mean was a half, what we'll do is we'll say the range is going to be from 70 or 67 to 73. So I've just rounded these up because we have all of these here, right? So remember, when we go to 61 to 62, it's including 61 up to, but not including exactly 62. And then including 62, not including up to 63. So 62 plus whatever, right? 62, all the decimals up to, but not including 63. That's how we show that. So within two standard deviations, it's going to look like this. So I'll just steal this. But this time it's within 2 standard deviations. So we have to multiply it by 2 times, right? So within 2 standard deviations. So we multiply the 3 by the 2, which obviously gives us 6, right? So that's 69.5 minus 6.0, which is equal to 63.5. Okay? And then we do the same thing, only this time we add, right? So because it's plus or minus, so plus the 6 this time, plus the 6 this time. So we end up with 75.5 within 2 standard deviations. So we'll just round those again like we just did in the previous question. All right. So when we round those values, we get 64 inches up to 76 inches. Sorry. Okay, up to 76 inches. And within 3 standard deviations, again, you're doing the same thing. So I'll steal this. And it's within 3 standard deviations. So you're actually subtracting 9 this time. And that will give us 60.5. And then we'll do the same thing again, only this time we're going to add the 3 standard deviations. We'll add the 3 standard deviations, so that's adding 9, which gives us 78.5. So that means the range within 3 standard deviations is going to be 61 inches. Oh, sorry, 61 inches. So 79 inches, which covers our data pretty much everything here. Okay, so we're going to talk about this. Basically what we're doing is we're developing what's called the normal distribution, and there's a little rule of thumb that we're going to talk about. So number of males within one standard deviation, so we have to add them up, so it's everything between 67 to 73. So 67 will not include these, so it would be 67 to 68. So 67 up to, but not including, so we'll go right to here. So our data range is going to be from 67, so right here, 116. So we're going to add these up. All right, so we're going to add 116, 128, plus 147, plus 129, plus 115, plus 63. We'll add these data up, and then we'll divide them by 1,000 to figure out what percentage is within that category. Okay, so I've added up 116, 128, 147, 129, 115, and 63, and I got 698. And we'll divide that by 1,000, multiply by 100, and that is equal to 69.8%. So that means that there are, the percentage is 69.8% of males were within one standard deviation, so 67 inches up to 73 inches. So 2 standard deviations, we're going to do the same thing. So we're going to count up, so we're going to include all these, right, plus the rest. So we're going from 64 to 76. So remember, we're not including the 63 to 64. We're starting here at 64, and we're ending at 76 here, right? So we already have the 290 or the 698. So from here, we just went and we're going to add we started at 116, so we're going to add 64 plus 52 plus 30. So we're just going to add these 3 more categories. Right? We're not including the 18 here from 63 to 64. So it's up to, but not including 64. This is 64 up to, right? So we added these 3 numbers. And down here, we stopped at 63 before, so then we're going to add till we get up to 76. So 53 gets us to 74, plus the 29 brings us to 75, plus the 20 brings us up to 76. And we get, when we do that, we get 948, which is 94.8%. So that means that 94.8% of the 1,000 Canadian males from ages 20 to 39 that were measured fall within 2 standard deviations. All right. And then the last one, within 3 standard deviations. So this is 61 inches to 79 inches. So 61 and shorter aren't included. So the only ones we're not including are these 3, because this one here, it's up to 79. These are all taller than 78. So the only ones we're not including are the 3 here. So that's 997. So the only 3 missing. So 99.7% fall within 3 standard deviations. Right? Okay? So is the data normally distributed? Yes, we could have answered this prior to doing this question, but we're going to talk about these percentages and what they represent in a minute. Yes, the frequency, as you can see from up top, the frequency polygon is symmetrical. Symmetrically distributed around the mean. So that's it for this video, and we'll continue on next in the next video with 68, 95, 98, 99. Well, thank you.